Hello everyone, welcome to my chemistry channel BL the Short and Sweet in Chemistry. Now I am going to explain the topic conformation of hydrocarbon related to alkane. That means here we can see ethane. This is part 3. We will see the Saw and Newman projection for staggered and eclipsed form for ethane. Because this is the main important part, ethane. And ethane, I told in part 2, there are two types. One is eclipsed, another is staggered and form. And here again this is the scientist who Saw and Newman who gives the different type of projection for the staggered form and also eclipsed form for ethane. So first is Saw model. In this projection, the molecule is viewed along the molecular axis. That means when Saw model you will see we will see the molecule along the molecular axis. Important. How can you see molecular axis? You see, and how it looks I will explain. The central carbon-carbon bond is represented by a straight line. The central, that means one is carbon-carbon single bond, that is sp3 overlapping, that is represented by a straight line. Now you can see how it is explained by a straight line. The straight line is tilted to the right. Remember, now the straight line is tilted to the right. That means here we can observe if you see the straight line, that is carbon-carbon representation, that means here you can observe this is the carbon-carbon single bond and it is the covalent bond and tilted to the right. Upper end of the line, this upper part line is slightly towards right and left hand side. That means here generally upper end line is slightly tilted towards right or left also. Front carbon is shown, now it is tilted to right. Now front carbon is shown by at the lower end of the line. Front carbon, when from this molecular axis you viewed from this molecular axis, so the front carbon is shown the lower end of the line. This is the front carbon we can view. You can view, that means you can observe, you can see according to the molecular axis, and the axis is represented by a straight line. Each carbon has 3 lines. Why 3 lines? Because the 3 hydrogen atoms are attached to it corresponding to 3 hydrogen atoms. Now I will show the diagram and how the hydrogen atoms are attached. That is one above the line above the carbon atom, front line, and the upper end, and that is other one is lower end. And the front carbon, that is lower end. And here the line is inclined at an angle of 120 when the hydrogen atoms are attached, and you can observe this is the 120 angle. Now see how, because the Saw's projection is there and that should be represented by 2 forms. One is staggered form, other is eclipsed form. What is staggered form? I told staggered form means they are far away from each other, and eclipsed form means they are close to each other. That means this is C1 carbon, that is upper end, and this is the C lower end. And lower end you can view from this side. This is the first carbon. You can view from this side. That means now see this hydrogen, how many hydrogen? 3 hydrogen. 3 hydrogens are attached to this carbon and 3 hydrogen atoms are attached to this carbon. Now this is the Seahorse representation for staggered form, and now far away from each other. The hydrogen atoms are far away. See what is distance? This is the distance, this distance where we can see far away. Eclipsed form means Saw's represented. Saw's representation for the eclipsed form, that means it is straight line. One is carbon, here one carbon. They are close to each other, that is called eclipsed form. Eclipsed form means they are close. So here you should write close each other. Close each other, and this is the that is called eclipse form, and first this is staggered form, far away. So remember, this is the Saw-Hersh projection, and then you will observe Newman projection. Saw-Hersh clear, it is a straight line, either tilted to right or left, generally tilted to right side in the lower end of the carbon, that is the first, that side you can review, and you can observe. And now it is Newman projection. What is Newman? Newman, one scientist who also give one projection about the eclipse and staggered form. In this projection, the molecule is viewed. See, and that side, the molecule that is, what is that one? Saw-Hersh projection. What happened here? Saw's projection, it is viewed from the lower end of the carbon. And what happened here? In this projection, the molecule is viewed along the bond line joints. Along the bond, that means bond line, that is a straight line between two carbon atoms. And here you can view. Then how? The carbon atom nearer to I, you can view that bond line, that means bonds joining, and here it is viewed near to the I. Then carbon atom, when it is near to I, that is represented by a point. That is only by a point. And three hydrogen atoms attached in front of the carbon are shown by the lines drawn an angle of 120 degree to each other. Remember, here in also Saw-Hersh projection and Newman projection, and one hydrogen, other hydrogen, here when you observe, the angle is 120 degree. And now you can see how the Newman projection is there. Now, the rear carbon atom away from the I, which can observe the how this is staggered form. In staggered form, that see, one is dot line structure and other one is straight line structure. That means you can see what happened here, represented by a circle, because you can see that between the carbon bonds you will observe, and that is why it is represented by a circle. That is why you can observe from this side, here this side. You observe from this side, here one hydrogen attached, the angle is 120 degree, and here also the angle is 120 degree. Now the dot line hydrogen, what happened here? Just behind, just here behind the that means you can observe this is the angle that above one hydrogen, below this hydrogen, that angle, and one hydrogen, this hydrogen, the angle both are different. It is 60 degree, it is 120 degree. That means you can see near the eye, the one hydrogen different by other hydrogen having 120 degree, and hydrogen atoms are shown attached it by the sorted line, and now the back side which is present, that is by sorted lines, and the angle is 120 degree, either between sorted line or between straight line. And now see, it is staggered form and eclipse form. In eclipse form, you can observe this dotted structure, sorted line structure, that is nearer to first hydrogen. So two hydrogen, they are near to each other, whereas staggered form, they are far away. That is why, see, you can observe this hydrogen dotted sorted line structure, that is far away from the first hydrogen. So you can observe this is the Newman projection, where you can feel that about one hydrogen, other hydrogen, the angle is 120. Staggered conformation were rotated through an angle of 60. That means here staggered form 60 changed to, because that is a far away from each other, but in eclipse form that is not 60, the close one. And here Newman changes to eclipse. Yes, here staggered conformation can changes to eclipse conformation by the rotation of 60 degree, because already it is far away, and when it changes to eclipse, that means 60 degree rotation. Newman projection is planar projection, that is 2D structure. Newman projection is not a space one, 3D structure. It is a planar represented by 2D structure, that is two-dimensional representation. Skew conformation. I told when there is a small change between eclipse and stagger, and that is called skew conformation. The skew rotation. The infinite other conformation of ethane lying between the extremes is called skew conformation. That means when there is an infinite number of conformation and here and some conformation lying between them, that is, it is called intermediate conformation, intermediate step, when you will get a skew conformation. Then what is the relative stability? You know about that is, first one is Hirsch projection, second one is Newman projection. Newman projection represented by circle 1, and below that other hydrogen atoms which are attached, and that is far away, that is your staggered. If close to first hydrogen view, that from your eye view, then it is called eclipse. Eclipse means close and staggered means far away. And by the scientists Hirsch and Newman, who said the projection, and that is very much useful. And now you can see what is the stability of conformation of ethane. Because when you see there is a infinite rotation takes place in ethane, but a very less chance here due to repulsive strain that between the electron pair, and that is why there is some repulsive force existing, that is called torsional strain. Now conformation of ethane do not have same stability. Conformation, there are two types of conformation I told. One is eclipse conformation, another is staggered conformation. Eclipse conformation, that hydrogen atoms are close to each other, and staggered conformation, hydrogen atoms are far away. That is why the staggered, the two conformation, eclipse and staggered form, they never show same stability. One is more, one is less. That question is why. In staggered form, the electron clouds of carbon-hydrogen bonds are so far apart as possible. Staggered form means far away. That means the electron cloud, carbon-hydrogen bond, they are far away as possible. So minimum repulsive force existing because they are far away. If the electron clouds are near to each other, then the repulsive force is more. But in staggered form, the hydrogen atoms are far away. That means electron clouds of carbon-hydrogen bonds are far away. If far away, then what happened? There is no repulsive chance or minimum repulsive force. That is why, since there is a minimum repulsive force, that is why it is called minimum energy and maximum stability of the molecule. That means in staggered form, there is a stability is more. What is the cause I told? Because a repulsive force is less or minimum. Since minimum, then why I told? Because the electron clouds of carbon-hydrogen bond, which is sigma bond, and now here they are far away from each other. Then here, if you want to see, then what happened? When staggered changes to, because I told staggered form can also change to eclipse form, then what happened here? And the electron cloud, the carbon-hydrogen, if it is eclipse form in, the hydrogen carbon, they are close each other. That means electron clouds of carbon-hydrogen bond, they are close to each other. If each other, then what happened? The electron cloud repulsion is more. Because carbon-hydrogen bond, the electron cloud, they are close to each other, and the repulsive force, electron cloud repulsion is more. If it is more, then what happened? There is energy, possess more energy and less stable. Less stable, and here first case, that is. So, you can compare staggered form and eclipse form in eclipsed form, the electron clouds of carbon hydrogen bond that is come to close each other. That means it is resulting in repulsive force more, so the less stable, more energy. The repulsion interaction between the electron clouds affect the stability of the conformation, that is called torsional strain. So torsional strain means the electron repulsive force, or you can say before that also I have told the electron pair, that electron cloud repulsion. Then here I can explain, I have explained why. Because when they come to close each other, the more repulsion, and when they goes away, far away, less repulsive force. And then come to here, magnitude of torsional strain. Magnitude means value of torsional strain depend upon the angle of rotation. Angle of rotation about CC bond, that is the main factor. Conformation means rotation about the CC bond in ethane, and that is why ethane shows conformation. This angle is called dihedral angle or torsional angle. That means when there is a electron cloud repulsion between the CC bond or hydrogen CH and CH bond, now this angle is called the torsional strain, and the angle is called torsional angle. So staggered form has least torsional strain. Because I told here what is staggered form, the hydrogen away from each other, and eclipsed form close to each other. That is why the eclipsed form, that maximum torsional strain, in staggered form least torsional strain. Infer that rotation around CC bond in ethane is not complete freely, though we can say the conformation existing in ethane. Why? Because rotation is possible, it is free. When we come to close about staggered and eclipsed form, you can conclude the rotation around CC bond is not so much free due to torsional strain, where there is a least torsional strain in staggered form and more or maximum torsional strain in eclipsed form. That is why you can conclude that in ethane also the conformation is not completed. Though you know conformation takes place in ethane, but it is the conclusion point. Now the energy difference between the two extremes. Now here staggered form 1 energy and eclipsed form 1 energy. When you calculate the difference between two extreme form, what is the difference energy? That is 12.5, and which is very small, 12.5 kilojoules per mole. That means for 1 mole 12.5 kilojoules is the difference in energy. It can be said that rotation about carbon single bond ethane is almost free. Why we can say conformation in ethane is possible? Is we can observe, we can feel, and so many scientists observe also. Here you can see the carbon single bond rotation is free. It is also last conclusion. Why? Because the difference in energy is very, very small. It is not so much effective to the rotation. That is why you conclude, yes, conformation takes place in ethane. So in practical you can observe ethane conformation takes place, carbon-carbon rotation takes place, because the energy difference is very, very small. It cannot affect. Effect means very, very less effective for the free rotation. That is why we can say rotation takes place and conformation takes place in ethane. It has been possible to separate and isolate. It is because due to very, very small energy difference, it has not been possible to separate and isolate different conformation isomers of ethane. You know, especially one is eclipsed form, one is staggered form, and between so many infinite number of conformation rotation takes place. And now here it is not possible to separate different conformation, and also you can't isolate also, because here so many infinite number of takes place, and that difference one form to one form, that is eclipse form to and staggered form, the energy is very small. Then how can you separate or how can you isolate the conformational isomers? So it is not possible. So it is not possible to separate and isolate the different conformational isomers, that is so especially you can say eclipse and staggered form. And 12.5 energy, that is very very small, that is why it is a barrier. If you cross that barrier, then free rotation takes place, and it is also very small energy, very small barrier to rotate for the rotation, very small energy to cross over is called torsional barrier. Torsional barrier means here very small energy and barrier that you can cross, that it is not difficult. That is why free rotation takes place. This energy difference is not enough to prevent rotation. So I told this is very very small energy. This is not enough that how to prevent rotation. To prevent rotation, that is from eclipse form to staggered form, so many infinite number of rotation takes place. You can't prevent because this energy is very very small. This is not enough to prevent. Even at ordinary temperature, the molecules have thermal or kinetic energy sufficient. When you see at ordinary temperature, the molecules have thermal, that is called kinetic energy, that is sufficient. That means kinetic energy, that means to move, to rotate, that energy is sufficient to overcome the 12.5 kilojoules per mole, and that is called energy barrier. And that means here the kinetic energy there between a molecule that is more sufficient, that means it overcome that 12.5 kilojoules per mole. So two conformational of ethane here you can observe. Therefore, two conformational of ethane, staggered and eclipse, go on changing from one form to other, and consequently also it is not possible to isolate the different conformation of ethane. Why? Because I told there is a very small energy difference, and in this 12.5 energy difference, so many infinite number of rotation takes place, so many infinite number of structures are there, and final staggered and eclipse. Staggered changes to eclipse, eclipse changes to staggered, but here isolation is not possible. Isolation is not possible because it due to very small energy difference. And here you can observe correctly. Again you see this is staggered form, and this on the above circle the hydrogen, and there are three hydrogen, this one, and this, and this, and the angle difference is 120 degree. Now this hydrogen, how can you say this one? Okay, by dot line. And now this is the hydrogen, and this hydrogen also 120. This hydrogen, the angle is 120. But when this one and shorted line, straight line and shorted line, the angle is 60 degree for staggered form. That means far away. In eclipse form, the short line that is near about the straight line. That means they are very close to each other. That is why it is called eclipse form. So this is the close one, hydrogen, and this is the far away one. So I hope it is clear to you. Here you can observe staggered form, eclipse form. Eclipse means close one, staggered means far away. One hydrogen separated from other hydrogen by 120 degree. So hope it is clear to you. That is the different forms of eclipse and staggered form of ethane, and also the Newman projection, and other one is Sawhurst projection are there. I hope it is clear to you. Hope you will subscribe my channel BL Das, short and sweet in chemistry.